Good evening. I have yet another monster receiver on the bench tonight. Top of the line for 1980, the Sansui G9700 with 200 watts per channel into 8 ohms.
Now you might be asking, Andrew, haven't you shown us a receiver like this before? Why, yes I have. The G8700, which is just like this receiver, only this one has a little bit beefier output transistors and a little bit higher supply voltage from the power supply. So, that means our refurbishing steps are going to be pretty much the same. We're going to start by taking care of some weaknesses in the system to these drive boards here. We're going to replace the bias pot and the offset pot. We're going to replace all the caps. We're going to put new thermal compound on the driver and pre-drive transistors. I'm going to check for cold solder joints and cracked solder joints. And I'm also going to check the fusible resistors. If I find one fusible resistor bad, I will change them all. They do tend to be bad in some units from Sansui, although these tend to be a little better at it than, say, a G, sort of the 9090 in the earlier G series. There's also the tuner power supply board. It needs to be recapped and cleaned. This unit is quite dirty internally. I'm not really sure why. Perhaps it was stored in a barn or something. It looks like there may have gotten a little bit of water there, but it's nothing too bad. Definitely not water damaged. There are some weaknesses in the 9700 and 8700 that you cannot correct, at least not without redesigning the driver stage. The bias doesn't seem to be correlated to temperature in any way. There's no temperature compensation element on the heatsink. The only thing there is on the heatsink besides your transistors is a pair of thermal sensors for the protection circuit, which will mute the output if the heatsink gets too hot. But as for something like a VBE multiplier on the heatsink, nope, that's not there. Not even a lousy diode in the VBE multiplier on the heatsink. It's kind of a bad design if you ask me. And don't take my word for it. Dr. Russell at UT Arlington would also probably be quite angry to see this, especially in something this high end. And what's really odd is that the G9700 series and smaller do have thermally compensated bias. Go figure. The units that needed it the most likely to overheat, don't have thermally compensated bias. And we wonder why we see these things with blown output transistors. Well, actually, the other reason you see these with blown output transistors is they are designed only for 8 ohm loads. It's a bit unusual, especially for something this big and this heavy. This is 22 kilograms of receiver, and it will only drive an 8 ohm load per the user's manual. Do not put 4 ohm speakers with one of these receivers, either the 9700 or the 8700. You will drastically shorten the life of your output stage. You'll also probably encounter the protection limit rather quickly. I have actually put 4 ohm speakers on one, but I didn't press it. I asked only for about a quarter of its output power, and yes, it did get kind of warm, even at a quarter output. So, there is another board. We'll have to recap this board, and if I remember correctly on the G8700, the legend for one of these caps, the polarity legend, is wrong. So if you recap this board here, make sure you note the original polarity, because if you trust the legends on the PCB, you might put in a cap backwards. And you don't want to do that, because it kind of goes boom. It's only the main power board for the entire amplifier. Wouldn't want to fault there at all. Anyway,
I'm also going to clean the front panel. It is kind of dirty and nasty. There are a few little scuffs, nothing too major though. It's in overall, I would say 8 out of 10 condition, except for the speaker jacks, which are absolutely trashed.
You just see there's just no springy action at all in there. That's the only negative terminal that works. I'm going to have to replace those with binding posts somehow, probably by fabricating some sort of mounting plate. Like with the G9700, there are also a lot of boards underneath this unit that we will get to later in another video segment. Those also need to be recapped. One board has a couple of VD1212 diodes on it. Those need to be replaced. Thankfully, they're not in the bias section on this amplifier. They're only, I say only, used as voltage references, which is bad in and of itself, considering the VD1212 is rather unreliable. So, once all that's done, we'll be ready for formal testing, and then I'm going to have to do one more thing. I'm going to have to set this one for 240 volts, and then package it up really well, because this one's going to Sweden. That's right, its owner is in Sweden. He bought this thing on eBay US, for around 800 USD. My refurbishing process is going to cost, depending on how much service he wants, anywhere from $300 to $550 USD. So somewhere in that $300 to $550 range. And then shipping, I don't know. It depends on how fast he wants it. It could be a couple $100 if we put it on a ship. It could be up to $800 air freight. So if you're overseas and you're thinking about buying a monster receiver from America, do consider the shipping. It can be quite nasty. I wouldn't want anybody to think, oh, I can't find one of these in Europe. I'll just buy one from America, where everybody loved receivers, and find out that it was probably cheaper to find the rare one in Europe because of the shipping. Oddly enough, it does seem to be that in Europe the separates are more common, and that's a bit of a shame in my book because I actually like the separates more. I'd have a better chance of finding what I want in Europe. Maybe next time I visit Europe I'll have to bring something home. I have plenty of transformers. Anyway, this is a large receiver with a lot of boards to recap, so I better get on it so I can get this back across the pond to its owner in a relatively reasonable amount of time. Alright, let's get started.